Right, so projectile motion, a couple of things to be aware of. Your syllabus has the equations written in quite an unusual way. And if you have a close look at your textbook, you'll see it's the same. Well, not quite the same, similar, but they've got them written in this weird way that looks quite strange. But it's still the same old formulas that we've always used. They're just written slightly differently. So instead of V equals U plus AT, they've changed all of the A's to G, which I guess is fair enough because it's going to be the acceleration due to gravity. So they've put a G in instead of the A. But why they've swapped the order of the terms, I don't know. So instead of it being V equals U plus AT or S equals UT plus a half AT squared, they've written it in this different order. The other thing that makes it look a bit weird is they've it's a new word. They've put these subscripts Y and X in for the vertical and the horizontal motion. Remember that vertical and horizontal components of the motion are independent of each other. So they've just done that with subscripts. I always write horizontal or vertical for whichever way I'm working. I'm sure if you did that in the exam, that would be fine as well. But just be aware that this is the way the formulas look. So don't be thrown when you get into the test and you look in your data booklet and the formulas look completely different to what you always used to use. So the Y is just talking vertically, the X is talking horizontally. Remember, the velocity doesn't change in that horizontal motion. That's why they've got Vx equals Ux. And the horizontal displacement is just that initial velocity, which isn't going to change by the time of flight. And that time of flight is going to be determined up here in the vertical motion. All right, so don't be freaked out by that. It's not too hard. All right, have a quick flick through here. As I just said before, that light's a bit annoying. As I just said before, the acceleration is always going to be 9.8 meters per second squared. It's always going to be a free fall situation. Is my lens really dirty? Looks dirty. I don't know. No, I don't think that made any difference. The horizontal displacement, that's called the range specifically. Important thing to realize, if you've got two balls, they fall at the same rate. It doesn't matter if it's just dropped down or if it's projected horizontally. They will fall the same distance in the same time interval. All right. Won't worry about all these simple little ones. Your textbook puts these, it uses the subscripts, but at least it puts them in the normal order. V equals U plus AT. I have no idea why your syllabus has done it backwards. I've never seen it in all my years like that. Right, these are pretty straightforward. We know all about splitting vectors apart and putting them back together. I think we've done plenty of those examples. And at an angle. So a question like this one is starting to get a little bit tricky because the ball is not landing at the same height. It's going further. You can still do it in one step as long as you're really careful about your positive and negative directions. So traditionally downwards is negative. So this displacement here would be negative 60. Right, that's going to make all the difference. The initial velocity is going to be upwards. This initial vertical is going to be positive. And your final displacement is going to be negative. And you can do it all in one go without any problem, as long as you're really careful about that. Complementary angles, so angles that add to 90, you get the same range. Now, this is a theoretical range. It's a parabola because the range is a function of t squared. So S equals UT plus a half AT squared is going to give you a parabola. In real life, on a bit further on the next page, they've got some diagrams there that show you with air resistance and drag in it, this parabola gets shortened quite significantly, and also it's no longer symmetrical, right? So, and usually it's lower as well, not quite so high, and it's definitely a shorter range. So complementary angles, you will get the same range from them. So 75 and 15 adds to 90, you get the same range. 30 and 60, you get the same range. It's easy enough. Quick look through here, the review. Vectors are joined head to tail, we know that. Vertical and horizontal components of velocity are independent, we know that. Angle to the horizontal is called the elevation angle. Interesting thing that you can use sometimes depending on the problems. Not this sort of problem because it's landing below, but in this situation where it's coming up and landing at the same height, this velocity here is the same as the velocity there. It's just now that the vertical component is downwards instead of upwards, but the numbers will all be the same. And that angle that was in here will now be in there if you need to work that for any reason. All right. You just need to be careful, as I said before, and get all your positives and negatives sorted out, and you'll be right with that. I was going to tell you some other trick. Can't remember what it was. Oh, don't forget also that at the very top here, our vertical velocity is 0. That's very useful. We use that a lot. All right, I had a go at one of the questions from the back here. Oh, I know what I was going to tell you. I was going to tell you, often the question will be, what's the range? What's the horizontal range? Or what distance did it land from the base of the cliff? If it hasn't given you all of these little steps here to get you started, sometimes they'll say, oh, that's scaffolding. That's giving you hints on how to do it. So it might just say, this is the situation. What's the distance? Remember that you need the time of flight. That horizontal distance is determined by two things: the initial horizontal velocity and the total time of flight. So you've got to find that time. It may be that you have to use v equals 0 up here or something like that. Or as I said before, if you're careful with this and the negative displacement, you can do that in one go to get the time of flight. Right. It's handy when the final velocity is 0 because then you don't have to use quadratics to solve for time. I don't think there's anything else there. Righto, this question. I thought this one, it's backwards to normal, so I did it. A boy kicks a football off the ground and it lands on the roof of his home 57.3 metres away at a height of 3.8 metres. The time of flight was 3 seconds. So this time we've actually got that range and got the time of flight. And we have to work backwards to get the launch speed, so the initial speed. Got this sexy purple pen that I found. I actually don't like it, but anyway, it glitters though. So, ooh, I don't know. Makes physics more exciting. Here's my diagram. Always do a diagram whenever you can. So we've got our diagram. Here it is, 57.3 metres and 3.8 metres up in the air. I should have drawn his angry mother here. Cranky because the ball has landed on the house and she's like got her hands on her hips. She's not impressed about this ball landing on the roof. Righto, total time 3 seconds. So I haven't put all those little subscripts in. You can if you want to. I've just gone horizontal, S equals UT. So I know the distance was 57.3 and I know it took 2 seconds. So that now I've got my initial horizontal speed, from that, 57.3 divided by 3, 19.1. Vertically, it's going to end up being positive 3.8. Acceleration will be negative 9.8, and we know the time was 3. And what I really want is that initial, because I want to combine that with the horizontal one to get the initial velocity. So it's just s equals ut plus a half at squared. S is going to be positive because it's up in the air. Negative 9.8 for the acceleration. Worky, 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 16. All right, so I'm going to put those two together. Usually in these problems, we've got a single vector that we're splitting into horizontal and vertical. But this time we've got the horizontal and vertical and we are recombining them. So just recombine using Pythagoras, and tan tells me it was at 40 degrees. So the initial velocity was 24.9 meters a second at 40 degrees to the ground. Or angle of elevation, 40 degrees. Then it wants to know what was the maximum height that it got up to. So remember, at our maximum height up here, v equals 0. So that's a useful fact. So at the maximum height, v equals 0, we have our initial vertical that we worked out before, negative 9.80, and we want s to get that maximum height. Worky, 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 13 meters. Part D, it says what time of flight for the complementary angle. So we know it was 24.9. The complementary angle, instead of 40, it's going to be 50, because 40 plus 50 gives you 90. And then we're splitting that into a vertical and a horizontal component. And you will have to use your quadratic formula, which I don't know. What is it? Square root b plus minus 4ac something to solve for t. So I know that you guys will be able to do that because you're smart. And that just about wraps up projectile motion.